9.14. It says that a mat foundation, again, I explained this briefly, just means it's not individual small foundations for a big structure. It's just one big giant rectangular foundation that is the same size as the building. That's what we call a mat foundation. And so let's say that it is 20 by 50, and that is the entire structure. But if we want to know a point right below the center, you can't do that. It can only be on a corner. So I'm going to have to make a rectangle that looks like that. And so this would be what, 10 by 25.
Yeah.
Okay, and I'll call that rectangle number 1. The other rectangle, number 2, 3, 4, they all happen to be, because it was right in the center, all these rectangles are the same exact size. And so I want to know the total induced stress, but that is the sum of the rectangles.
Yeah.
So 4 individual rectangles, just add them all up. But in this case, if they're all identical, the same B, L, Q, and Z, then I can just pick one rectangle because it's the same as all the others and just multiply it by 4.
Yeah.
But yes, you can't use the given 20 and 50 meters because you have to break it up into smaller rectangles. That's the B and L you have to choose. So in this case, it would be, each rectangle will be 10 by 25.
Yeah. Yeah, that was my mistake, because I was like plugging it in, because we have to plug it into like different equations and then use the Newmark chart. And I'm assuming that was the issue right there. The B and L values were not correct. So
Yep. And it says use Boussinesq's method, compute the induced, first use the full analytical solution. Is either equation 934 or 935, then do it again using the approximate method, then do it again using the chart. So this way you get some practice with each and you get to see sort of the relationship, how they compare to each other. Again, if you read the chart really well, it'll give you the exact same number as the equations.
Okay, so I'm having a lot of difficulty with the equations because, one, they're like so long and hard to put into my calculator, and then the other one is it in radians or is it in degrees? Is another question that I need to know for my calculator. You know, is the equation in radians or degrees? Because you're asking for a sine inverse.
Those are radians.
Radians. Right? Okay.
Right? Yeah, those are radians.
And the B and the L are not the B and the L of the whole square. They are the B and the L of your individual square with the dot on the corner, correct?
That's right. Yes.
Okay.
Always.
So I think I need to change my calculator to radians. I think that's why I'm not getting correct numbers.
Yeah, that might be it. Let me see. I don't know if that's in like the fine print for those equations. It might be there, but let me check just for my own knowledge. Equations 934 and 935, right? Yeah, they're sort of big and long equations.
Yeah, I'm going to have to piece it up because I was trying to do it as one big equation, and it was taking me forever, and I kept screwing it up. So I think I'm just going to have to piece it up correctly and figure it out.
Right. Yeah, it says right here, right below the equations in the textbook. It gives notes. Note number 1. The inverse sine term must be expressed in radians.
I did not notice that.
Also, B is the shorter dimension, L is the longer. Right, okay, yep. Yeah, it's a long equation, yes. You do it in chunks and piece it together, yes. Just be careful. Might actually be easiest to just put it in MATLAB. Little chunks at a time. Type the equation into MATLAB. Actually, honestly, that probably would be really easy because you could leave B, L, and Z as variables. Put it in chunks of the equation. Then you just type in just change B, L, and Z, and you can do the next problem. You know what I mean? That's up to you. But yes, the inverse sign is in radians. Okay. Any other questions?
Just a general question. So you yesterday you mentioned that the distance of Z is like the distance from where the pressure is acting on the surface, not not from the ground surface down, you said. So
Right.
like, were you referring to like if there happened to be an excavation, like a common mistake would to take Z from the ground surface down to that point instead of from the bottom point of the excavation?
Yeah, you gotta remember that it's always about influence. So it is not what is the influence of the original ground surface, but let me look at it this way, right? So I take this original ground surface, and we have a point of interest that's maybe, I don't know, 40 feet down, let's say. And that point is right here. Point A is the point of interest, okay? And so before any construction, maybe this is how it exists. And we could figure out what is the, geostatic effective stress at point A, if you knew the density of the soil and whatever, right? So, but then we come along, we do some construction, and let's say it's an excavation. And so let's say we're gonna dig an excavation like this. We're looking at just the cross section, but in plan view, maybe it's a rectangle, right? So we're gonna dig an excavation like that. And maybe the excavation is, like maybe 18 feet deep, right? Something like that, perhaps, okay? What does point A experience? What does point A experience? Well, in general, in very simple terms, we probably expect there's going to be a reduction in stress. The induced stress is negative. It used to be geostatic. Now it's geostatic minus some stress from the excavation, right? This excavation is going to cause a reduction in stress at point A, right? But here's my question. A little bit more detailed and more in-depth. What happens? Well, very superficially, a reduction in stress. Yeah, but according to what factors? What is influencing point A? What is influencing point A? This excavation is influencing point A, not based on the original ground surface, but based on the fact that it is right there, very close to point A. For example, instead of 18 feet, what if the excavation was 38 feet? Now that excavation is getting really close to point A. And point A is going to have a really severe influence. You see what I'm saying?
Yeah.
Okay. So regardless of what the actual number is, let me go back to this 18. The fact is that it is this plane right here in the bottom of the excavation that is what experienced the change in stress. The question is, so again, let me call that point B. That plane at the bottom of the excavation is what experienced the change in stress. That is where the soil was removed from. That plane at the bottom of the excavation, right? Point B. So the question is, what is the influence of that plane? What is the influence of point B on to point A? What is the influence of that plane? What is the influence of the excavation? Is not related to the original ground surface. It's related to that plane that is the bottom of the excavation, because that's where the external load was applied, in this case a negative. That's where soil was removed from. And even We could be talking about a point outside the footprint, right? Maybe I call that point C. What is the influence of the excavation at point C? Still, the depth from the load to the point of interest is the F, not from the original ground surface. We're not talking about what's the influence of the ground surface on point C, it's what is the influence of the excavation on point C.
Yeah.
Does that make it a little bit more clear?
Yeah, that makes sense. Yeah.
And then, you know, perhaps then maybe a structure will be built, but right now we're only seeing the excavation. Maybe shortly afterwards comes a structure. Well, still, it's the same exact thing. It's what is the influence of the structure on point A and on point C, not the influence of the original ground surface. What is the influence on the structure? So the common mistake is a lot of people say, well, there is no excavation above point C, so shouldn't I just still consider all of the soil like it's still there? No, some of the soil nearby was removed and has an influence on point C, regardless of the structure. Okay, so again, we have to consider what is the influence, what is the depth below the point, below the plane where the load was applied, not the original ground surface.
Yeah.
Okay. So what point B experiences is Q net, which was in the end the difference between the structure and the excavation. That's what point B experiences, right? Or that entire plane experiences. Well, there was first a reduction in stress caused from the excavation, and then an increase in stress caused by the structure. Okay, so that Q net is what the soil at the bottom of the excavation and the bottom of the footing experiences, Q net, right? The question is, what's the influence on points like maybe A or C? And I'll say it again. The most common mistake is students figure there is no excavation above point C, so I shouldn't consider the excavation. But that's not correct. There is an influence from the excavation even though it's not directly above point C. Okay, just like there's an influence from the structure.
Yeah. Yeah, that makes sense.
So a lot of times, information might be given. Actually, notice in the first question, 9.14, it doesn't even talk about the original ground surface. It only says a point 15 meters below the center of the mat. 15 meters below the foundation. It doesn't even talk about the original ground surface. But other questions say, well, in problem 914, I think it's the foundation is on a ground surface, so there is no excavation. So in that case, the depth below the load and the depth below the ground surface are the same thing.
Yeah.
But in other cases, they'll say, you know, 917, same thing. It's a steel tank that is just right on the ground surface, right? But in other cases, they'll say, you know, there's a point that is, well, I did it right here. They'll say there's a point that is 40 feet below the original ground surface. And then they'll say, but a structure is going to be constructed that goes to 18 feet below. So really, what is ZF? Well, it's whatever's left over, right? It's got to be that, what is that, 12 feet? No, sorry, 22, right? So ZF is 22 feet. If it was originally 40 feet down, but the foundation is 18 feet down, then that difference is 22, right? So you got to read the question carefully and make sure you're considering the depth below the plane where the load is applied, whether that's a negative from the excavation or a positive from the structure. It's always the plane where the load is applied.
Okay, yeah.
That if your point of interest is above that diagonal line, that means it's having a negative influence on it. It's starting to
Zero influence. Once we get outside of that influence zone, it's probably zero influence.
okay.
Yeah, so if you go out wide enough or up high enough outside of the footprint, then if you get outside of the influence zone, that's when that influence factor gets really, really, really small, or maybe even zero. It's just not influenced by the excavation or the structure if you get outside of that influence zone. But again, exactly what does that influence zone look like? Well, that's where the equations in the chart come in. I'm giving you a visual here, but you know exactly what do those lines look like? I don't know. It's according to the equations in the chart.